Hello everyone, good morning. Today's lesson and the last lesson for this week, as well as this unit, is going to be a review of applications of exponentials. Okay, so you've seen applications already when we did exponential growth and decay, but I'm just going to review them one more time to make sure that we've really got them. Okay, so the first thing was exponential growth. Now, when we're talking about exponential growth, that means that the base of the exponential is bigger than 1, okay? And the function, the graph of it, will go up to the right. All right, now we looked at two different types of exponential growth. Okay, there were two different types of problems. There was doubling time and percent increase. All right, so just to review kind of both of those. Let's just get rid of this actually. Go away. Okay, so when we're talking about doubling time, our equation is A is equal to P times 2 to the power of n. Now the 2 means that it's doubling, right? It's being multiplied by 2 every time. A is your final amount, so that's usually what we're looking for, how much is left after so many doubling periods. P is your initial amount, what you're starting with, okay? N is the number of growth periods. Now we're going to do a couple of examples because the N was the trickiest one to find. Okay, so you take your total time and you divide it by how long it takes for whatever we're talking about to double, which is always given to you in the question. Okay, the doubling time is always given to you and the total time, and you have to divide them to figure out the n that you plug into the equation. Okay, that was one type of exponential growth. The other one was percent increase, where the equation is A is equal to P times 1 plus R. It's plus in this one because we are increasing to the power of n. The A, the P, and the R, the A, the P, and the n are the same thing as over here. But the R is the rate at which it grows. All right, it's always the percentage from the question, and it's always written as a decimal. So to put a percentage as a decimal, we divide by 100. Okay, so doubling time and percent increase are the two types of applications for exponential growth. Exponential decay, when we looked at those, is when your base is between 0 and 1, so it's either a fraction or a decimal between 0 and 1, and the graph goes down to the right this time. So it starts off really big and then gets smaller. Okay, our two types of questions here were half-life and percent decrease. So the equation for half-life looks really similar to the equation for doubling time, except the rate in here is a half instead of 2. All right, and really you calculate the n in the same way. You take your total time and divide it by how long it takes for whatever we are talking about to have. Okay, your percent decrease, again, very similar to the percent increase equation, except because it's going down, it's decreasing, we now have a subtraction in here. Okay, but again, your rate is always a decimal divided by 100. Okay, so the questions that I want to try hopefully look a little familiar to you. The examples that I want to go through because they are from your last assignment. Okay, I'm not going to rewrite all of the questions, but just take a look for me, okay, to assignment 2, and these are questions 2, 3, 4, and 5, which are just from the second page. All right, so going through question 2 here. Okay, so when you're reading the question, it says that Sydenham High School has a current population of 652 students. So that's your present value. All right, it wants to know what the population will be in 2023 if it decreases by 3.2% every year. So 3.2% as a decimal is 0.032, and your n is how long has passed since it started. So it was 2023 minus the current year, which is 2020. So 3 years will have passed. It's a percent decrease question. Okay, so we're using a is equal to p times 1 minus r to the power of n. You plug in your p, you plug in your r, and then you break out your calculator, and you should get 591.4, which it's a student, so we round to the nearest student, which is about 591. Okay, so figure out what type of question it is, plug in all your numbers, get out your calculator. Awesome. The next question, question 3 from your assignment, was about iodine 131, which is just a radioactive material. Okay, the question tells you that the half-life is 8 days. So it takes 8 days for it to become half of what it originally was. Okay, so if you had 100 grams of it, in 8 days you would have 50. In 8 more days you'd have 25. All right, so we use the equation a is equal to p times 1/2 to the power of n. It tells us that it's a sample of 95 grams, so that's our p-value. We're going to plug that in to the power of n. Part B says, using this equation, how much of the iodine 131 will be left after 40 days. Now, we don't plug in 40, okay, because the half-life is 8 days. So to figure out your n, you take the total, divide by the half-life, and that will give you the n value. Okay, so we plug in 5, and we break out our calculators. Okay, so those two questions were the first two. So we had percent decrease and half-life. So those were both exponential decay applications. Let's look at the next two. So question 4 from the assignment was about a vase, I think, a very expensive one. Yes, and it's expected to increase in value by 7% every year. So we have the initial price, $1,100. The rate is 7%, which we write as a decimal, and it's a percent increase question. So we use this formula here. We plug in what we've got. So 1 plus 0.07. The n is kind of given to you, excuse me, in this question. It says, because it increases every year, and we want to know what it's worth after 10 years, okay, we just plug 10 into the equation. There's not a lot of figuring out for the n there. Now I need to remind you, when you're typing this into your calculator, it's 1.07 to the power of 10. A lot of you multiplied by 10, and those are different things. So make sure you know how to use your calculator correctly. If you've got questions, come see me tomorrow in the Google Meet with your calculator, and I'll make sure you know how to type that in. Okay, because some of you got really silly numbers here that hopefully we can catch. Last one was the doubling time question. So it was about salmonella, I think. Okay, it gave us an initial amount of salmonella and said that it doubled every 20 minutes. So we use the equation a is equal to p times 2 to the power of n. We plug in the 450 because that's our initial amount. Here we've got to calculate our n value. It wants us to figure out how much bacteria is left after 3 hours. Okay, so this is a little bit tricky because the doubling time is given to us in minutes, but they give you the total time in hours. So you have to make sure that those things agree. So you've got to change them. So I changed 3 hours to be 180 minutes. Okay, so we take our total time, divide it by the doubling time, and that's what you get for your n. All right, and then that's what we're plugging over here for this n. And again, it's 2 to the power of 9, not 2 times 9, 2 to the power of 9 times 450. You do get a really big number for that one. Okay, so for today's practice, I've given you one more of each type of question. So a doubling time, a percent increase, a half-life, and a percent decrease. So there are 4 questions. I want you to try, okay? I will post the assignment later on this evening. Tomorrow's our Google Meet, and then assignment 3 will be due on Friday, okay? Best of luck, everybody. Let me know if you have questions.